Hello, welcome to another of my chemistry series video. Today we're going to looking through carboxylic acid, which is known as the alkanoic acid. Carboxylic acid have a general formula of CnH2 plus 1 and a COOH. The functional group is the COOH, which makes it polar, and it can be ionized as COO1- and H1+, which makes it an organic weak acid as the formation of an hydrogen ion. As we can see here, the oxygen combined to the carbon. The oxygen is partially negative as the carbon is partially positive, and the hydrogen is also partially positive as well. And it's a weak acid, so it wouldn't be fully ionized in the water, but it will be partially ionized. As you can see here, while they contain a R group, which means it is an alkyl group, the CnH2 plus 1. Alkyl group is nonpolar, which means it is fat soluble, but not water soluble, with the combination of both an polar and nonpolar, which means that it is a good solvent for many compounds, but the acidity restricted its use, such as the unwanted protonations. As you can see, the reaction of carboxylic acid. This shows us the acidity properties of carboxylic acid. If we have ethanoic acid react with an alkaline, we will make a ethanoate salt and water. As we can see here, reaction between the alkali, the group react with the alkali, the COOH, and we will form the NaCOO with the rest of the function group and one water molecule. With the bicarbonate, it will be a similar reaction, but now we have carbon dioxide formed. If the R group was just a H, we'll call it as methanoic acid. React with a sodium hydroxide, we'll get sodium methanoate and a water molecule. Same as this reaction, we'll get sodium methanoate with water and carbon dioxide. Reaction with metal, you will also form the salt, organic salt, depending on the function group, and have a hydrogen molecule here. We can see, so it wouldn't be formed fully. So you need two organic carboxylic acid in order to react with two metal in order to form a full hydrogen molecule. So it is H2. So here we write as half of a hydrogen. Esterification of carboxylic acid. The reaction between carboxylic acid with alcohol will make ester. This process is known as esterification. This is often done with an acid, which is like sulfuric acid. It usually is the catalyst for the reaction, which donates the proton, and the reaction is known as the Fischer esterification. Formation of ester. The reaction name will be esterification. As we can see, we have one carboxylic acid react with one alcohol molecule on the presence of acid catalyst, and it will form an ester and a water molecule. And we can see the key formed bond will be COO, if you can see here, but so will be CO bond between here and combined with the R, which is the alcohol over there. And the key bond broken is the OH bond, which represents the carboxylic acid. The reverse reaction will be known as hydrolysis, which can be often done with sodium hydroxide, or it can also be used acid catalyst since this reaction is reversible. Depends on the equilibrium, it will push to one side, depends on the condition. The formation of carboxylic acid. Carboxylic acid can be formed by microbial oxidation. So if we have a primary alcohol, such as ethanol, in the presence of oxygen and bacteria, later we'll get carboxylic acid, which is being used as the fuel source for the bacteria to live, and the rest of the product is the carboxylic acid. As we can see, if you get a bottle of wine and open it in the air, later few days we'll get wine vinegar. Or chemical oxidation utilize potassium dichromate, which is one of the key oxidizers in the GCSE syllabus. You can see first it will form the aldehyde, then eventually form the carboxylic acid. We can see here we have one ethanol. Under the presence of the oxidizer and some acid, you get acetaldehyde, which is known as ethanol, and then furthermore oxidized by the dichromate. Under the presence of acid, you get acetic acid. Warning, for the extra knowledge points, do not write this in a GCSE syllabus. In reality, permanganate, like potassium permanganate, is much more preferred since it is more powerful than dichromate. Due to the low price, low toxicity, and good self-indicator, intense purple, and the aldehyde will be produced by catalytic oxidation of alcohol over the copper or silver catalyst to produce aldehyde, then oxidized to carboxylic acid. So it saves time on the expensive oxidizer, and using catalytic oxidation over copper and silver, so it's much faster compared to using the permanganate salts, for example, or using dichromate salts. And one of the reasons for its low price of permanganate, because it's less restriction, since we can see low toxicity compared to dichromate, one of the carcinogenic compound. So that's it for this video, and hope you like it. And make sure to check out my other videos and consider to subscribe, and goodbye.